Now let's consider another question. So in this question we have copper has two isotopes, copper 63 and copper 65, with isotopic mass of 62.9 and 64.9 respectively. Calculate the percentage abundance of each isotope if the relative atomic mass of the naturally occurring copper is 63.55. So in this question, we are given the relative atomic mass of the elements and also the masses of the elements. The masses of the isotope present in the elements. But we are asked to calculate their abundance. How do we go by these situations as well? So first of all, let's write the information we have. We have the AR of copper to be equal to 63.55. Also, we have the isotopic mass. The isotopic mass of copper 63 to be 62.9, and then the isotopic mass of copper 65 to be 64.9. Is that okay? But we weren't given the percentage abundance for copper 63. We don't know. And also the percentage abundance for copper 65, we don't know as well. And in a question, we have to determine the percentage abundance of each of these isotopes. Is that okay? Now, first of all, let's write our AR relation. We know that AR for copper, Cu, will be equal to the summation of the mass of the first isotope times its abundance plus the mass of the second isotope times its abundance, all divided by 100. So we are using percentage abundance, so all divided by 100. Is that okay? But we know the mass of each of the isotope stated here, the isotopic masses, but we don't know the abundance. And also we were given the relative atomic mass of the elements. So how do we go by it? So first of all, we indicate the abundance of any of them with a variable. So we say that let y, or any variable, so let y be equal to the percentage abundance of, let's take copper 63. So let y be equal to the percentage abundance of copper 63. Is that okay? So if the percentage abundance of copper 63 is y percent, then what will be the abundance of the second one? Is that okay? What will be the abundance of the second one? So we know that the abundance, the percentage abundance of copper 63 plus copper 65 in terms of percentage should all be equal to 100. So if we say let y represent this, so y plus that of copper 65 is equal to 100. Then what will be the percentage abundance of copper 65? So we say that the percentage abundance of copper 65 will be equal to 100 minus y. Is that okay? Because if one is y, to know the other one, we subtract that variable or that number from 100. So if we say the percentage abundance of copper 63 is y, then the abundance for copper 65 will be equal to 100 minus y. Is that okay? Very good. So now let's proceed. So let's write it somewhere. Percentage abundance of 63, copper 63 is y, and then percentage abundance of copper 65 is 100 minus y. Is that okay? So we are going to substitute what we have here into our abundance equation. Is that okay? So AR, which was stated in the question to be 63.55. So 63 0.55 is equal to the summation of the mass of copper 63, that's the first isotope, and that is 62.9 times the abundance of copper 63. We said the abundance is let it be Y, so times Y, plus the mass of the second one, that is 64.9. 64.9 times its abundance. Its abundance is 100 minus Y, all divided by 100. Is that okay? So once we get here, let's do some mathematics. So what do? We multiply both sides by 100. So this is going to eliminate this. So I'm going to get 100 times 63.55 being equal to 62.9 times Y plus 64.9 times 100 minus Y. Is that okay? So now let's expand whatever you have here on both sides of the equation. So you're going to get 62.9Y. That is 62.9 times Y. It will be 62.9Y plus, we can use our calculator to assist us. We have 64.9 times 100. So 64.9 multiplying 100. We have 6490. So plus 6490. So over here, we need to expand what we have in this bracket. So the 64.9 multiply 100, and the same time to multiply the Y. Is that okay? So you are going to get 6490 for this multiplication, and then minus 64.9Y. Is that okay? We've expanded this bracket into this form. And then also we have here 63.55 times 100. And that will give us 6355. So once we get here, we group like things. We group like things. Is that okay? We group like things. So we can bring all the variables with Y to the opposite side of the equation, and then those without any variable to the other side of the equation. So once you bring them, so you're going to get 60, it was negative here, so once it crosses, it becomes a positive. So you're going to get 64.9Y, and then we have positive 62.9Y. Once it crosses, it becomes minus 62.9Y. Is that okay? And this is equal to 6490. So this one also crosses, minus 6355. Is that okay? Now let's do our subtraction. 64.9Y minus 62.9Y. We are going to get 2Y is equal to, with the help of our calculator again, 6490 minus 6355. What are we going to get? We are going to get 135. Is that okay? We are going to get 135. So what do? Over here, we need to get the value of Y. So we divide both sides by 2. So this 2 is going to eliminate this 2. So 135 divided by 2. And the answer is equal to 67.5. So Y is equal to 67.5%. Or Y is equal to 67.5. Now, the question here is, what is Y? Y was equal to the percentage abundance of copper 63. Is that okay? So, the percentage abundance of copper 63 is equal to Y will then be equal to 67.5%. Is that okay? The percentage abundance of copper 63, which was equal to Y, will be equal to 67.5%. How do we know the abundance of the second isotope, that is copper 65? So we said the abundance of copper 65 is also equal to 100 minus Y. Is that okay? It's also equal to 100 minus Y. So we now know Y. So to get the other one, so the percentage abundance of copper 65 is equal to 100 minus Y. And we already know Y to be 67.5. So 100 minus 67.5 will give us what value? And that is 32.5. Is that okay? So the percentage abundance of copper 65 becomes 32.5%. Is that okay? So that is the answers for the abundances of each of these isotopes in terms of percentage. Is that okay? So anytime you are given a question like this, that you are given the relative atomic mass of the elements and the masses of the elements, and you're asked to calculate the abundance, whether it is in percentage form or it is in fractional form, we use the same ideology. We say let a variable represent one of the abundance. Is that okay? And then the other one becomes 100 minus that variable. If it is in percentage, if it is in fraction, if one is y, the other one becomes 1 minus y. But if it is in percentage, if one is y, the other one becomes 100 minus y. Is that okay? Now let's look at another situation or another problem as well.